All right, I think we can get going. So thank you very much for joining another edition of our Liftoff webinar series. Today we are happy to welcome our good friends at Foley and Lardner to speak with us about IP considerations when looking at artificial intelligence, machine learning solutions, something that should be top of mind for people, but maybe isn't as they're knee deep in technology and trying to figure out how all this stuff is going to work. There might be some things to consider that that you might not have considered previously. So we're looking forward to that conversation. My name is Joe Steele. I'm the Senior Director of Communications and Legislative Affairs here with Lyft in Detroit. Thanks again for joining us today. A few housekeeping items to speak to before we get going. Everyone should be on mute. If you're not, please go ahead and do so, as we are recording this session. It'll be posted on our website at lyft.technology a little bit later today, and we want to reduce as much background noise as possible. If you do have questions during the presentation, please go ahead and use the Q&A function that's available on the Zoom toolbar at the top of your screen, or maybe it's the bottom of your screen, but somewhere on your screen where it says Q&A, you can shoot those questions to us throughout the presentation. Then we'll host a Q&A session afterwards. So we look forward to going through that presentation and having those Q&As afterwards. So don't be shy. I do want to take a couple of minutes to talk a little bit about Lyft for those who may not know who we are and what we do. Lyft is a nonprofit public-private partnership and a Department of Defense Manufacturing Innovation Institute. So what does that all mean? That means that we are driving American manufacturing into the future through technology and talent development. We know that on the future of our economic resiliency and security is advanced manufacturing, and the next industrial and economic powerhouse that tackles advanced manufacturing first will come out ahead. And as a Department of Defense Manufacturing Innovation Institute, we certainly want that to be the USA. So how do we do that? Well, we look at the connection of material science, manufacturing process, systems engineering, and the talent that runs underneath all of those to make them work. So we are heavily focused on material science and manufacturing process, making sure that we know what we need to make in the future, what we need to make it out of, and how we need to make it, making sure all of that is aligned, and making sure we have the people in advanced manufacturing to go ahead and produce those things that we need going forward. So we operate really two programs at Lyft. Leading Innovations for Tomorrow, which is our technology program, and Learning Innovations for Tomorrow, which is our talent program. So a little bit on the technology side, all of our technology programs fall under one of these pillars of technology. A little bit more in depth here. Don't worry, I'm not going to quiz you on any of these, but you can see we run everything from integrated computational materials engineering, easy for you to say, which is the development of materials and in the virtual space, making sure that we can know how materials are going to react when they're being processed, so we can not get out of the make it and break it phase physically. We can do a lot of this virtually, and this works well, particularly when we're talking about things like hypersonics weapons and hypersonics vehicles. We can't be testing those physically all the time, so the more we can do in the virtual space, the faster, better, and cheaper we can make things. Advanced alloy process development. Again, you see hypersonics materials development there. What do we need to make things out of that can go Mach 4, Mach 5, Mach 6, etc. And how do we join all that together? You see multi-material joining there at the bottom. We also work in the agile and smarter manufacturing space, new processes. Can we be more nimble with our manufacturing? Instead of thinking of things olden times like, giant stamping presses and things like that, can we utilize our manufacturing robots and other pieces in different ways? So if you have questions about any of these, certainly reach out to us. More information on our website, but we'll be able to give you some contact information before we leave here today as well. On the talent side of the equation, it's still about innovation and new learning, but this is about new learning tools, pathways, and venues. It all circles around our Lyft Learning Lab, which is in our Detroit facility. You can see behind me. That is a unique, immersive lab where students of all ages can come and learn at Lyft. Teachers can come and learn and develop new curricula. And that's where we developed our Ignite Mastering Manufacturing curriculum, which is a 3-year high school program that is rolling out around the country. It's available in about 10 states right now, 3,500 students each day participating in it, but really exposing them to the world of advanced manufacturing, from material science to advanced manufacturing systems. We also provide certification programs for our more adult learners, folks that are ready to take on jobs today. Both our Lyft certified program and Operation Next, things like CNC machining, welding, industrial technology, maintenance, and robotics. I mentioned those first three because those are the most in-demand certifications needed by advanced manufacturers today. And then robotics is the fastest growing. So I'll point out Operation Next, that's a little bit different than our Lyft certified program. Op Next is available to our separating members of the military right before they leave the service to help them begin their next career. Also available to members of the National Guard and Reserve and their spouses. A number of places around the country: Michigan, Kentucky, Florida, Wisconsin, Virginia, New York, Alabama. That is a program that is rolling out around the country as well. I would be remiss if I didn't mention we, along with being a nonprofit public-private partnership, we are a membership-based organization. So we thank Foley and Lardner for their membership. And this is a list of things that you receive as a member of Lyft and the Institute. Everything from being a trusted advisor, bringing you the expertise like today that you hear from with Foley and Lardner, a technology accelerator, taking those technologies from idea to prototype, crossing the valley of death to get them into the hands of the warfighter and in the hands of industry as quickly as possible. We are a technology showcase at our Detroit facility, showing you the art of the possible, what the future of advanced manufacturing looks like. We're a connector and convener. That's why we're all here today. So thank you very much for joining. We're a talent developer. I already talked about that a little bit in terms of our high school program and adult programs. And finally, we are a government partner. It can be unwieldy for folks to begin to work with the federal government. It is a big place, but we are a conduit for folks to do so. So I encourage you to reach out to us with any questions. Follow us on our social channels. Be happy to reach out to you there. But that is a little bit from Lyft. And now I'm going to turn it over to the Foley and Lardner team with Shabi and Robert. So I will stop sharing my screen and hand it over to you guys. Gentlemen, the show is yours.
Thank you very much, Joe. Appreciate the introduction. And I'll try to match that energy level. It was pretty well done.
I appreciate that. Thank you.
All right. Great. Well, everyone, thank you for joining. We've got about 15 minutes. We'll try to reserve some time for questions at the end. But if you have questions along the way, feel free to chime in or put them in the Q&A and we'll get to them at some point. I'm here with Rob Okanowski. I'm a partner in the Boston office of Foley and Lardner in the electronics practice group. Rob Okanowski is an associate in Detroit, and we work very closely together representing clients across the spectrum, from startups all the way to Fortune 5 companies, helping them protect their innovations and coming up with IP strategies that are both domestic and global. Foley's a partner of Lyft, and we appreciate the opportunity today to present to all of you. Certainly going to be excited to talk about strategies for protecting IP in smart manufacturing. Next slide, please. Great. So just from an overview of what we'll cover today, we'll start by just giving you a general understanding of what IP is. We'll go into sort of how do we protect IP in smart manufacturing, talk about developing an IP strategy, and then sort of shift gears a little bit and start talking about selecting and contracting with AI vendors, address some other IP issues that might arise in smart manufacturing that include ownership and NDA related issues, and then end with some Q&As. Great. So what is IP? Every company has it, even if it isn't registered. And there are typically two main types of IP, right? There's unregistered IP and then registered IP. And intellectual property is sort of the sibling of real or tangible property, in the sense that intellectual property is intangible in nature and generally, has some value, either to the company itself or the owner of the IP, or to a competitor or somebody else who would love to get a hand on that IP. So in terms of unregistered IP, anything in your company, for example, the know-how of how your systems work, the knowledge that your employees retain about the company is all considered sort of intellectual property. Trade secrets that you maintain, the processes, methods, and algorithms for how things operate, your computer programs, technical drawings, designs, analysis, research, licenses that you have with maybe third-party entities that you're obtaining sort of exclusive data from, is IP that you now have access to. And then in addition to sort of the technical side of things, just business information, your sales, research, marketing research, customer lists, understanding who your customers are, information about them, is all considered intellectual property that is maintained by the company. And then more traditionally, when we think about IP, we're really thinking about the registered IP. And that comes in the form of patents, copyrights, trademarks, service marks, trade names, domain names, and other forms of IP that can in some form be registered with a government agency or some other entity. Next slide, please. So moving on to some just basic intellectual property terms and types of IP. They're essentially, I'd like to call them, contracts generally aren't considered registered IP, neither are trade secrets, but there are 5 primary categories where you find a lot of value in the IP that you have. There are patents, copyrights, trademarks, trade secrets, and then contracts. And we'll kind of just spend a few minutes going through this chart to kind of tell you how they differentiate from each other and what the salient terms are for them. So patents are essentially a right to exclude others. The way that patents work is you are obligated to file a patent application in which you disclose how to make and use your invention, and in exchange for that filing that you do with the patent office, which eventually becomes public, you get 20 years of protection to prevent other people from making, using, importing, selling, or offering to sell your technology. Patents protect new and useful ideas. So there's a novelty component and a useful in the sense that it has to have some utility to it. It requires a disclosure to the public. It's 20 years in term. And then the cost of getting patents is relatively more expensive than getting other types of registered IP. And so hence the $4 signs there. Copyrights, in contrast to patents, basically it provides a right to make copies, allows other people to make copies if you have sort of a license to a copyright. A copyright, it protects creative expressions in tangible form. And so part of the requirement of a copyright is that it has to be creative. So for example, a customer list, if it's simply a list of names, does not warrant copyright protection because it's simply a list and didn't require any sort of creativity per se. It requires originality, can't be copied work, has to be original. And then the term of copyright is, the lifetime of the author plus 70 years. And essentially, because you can get copyright protection before getting it registered, it essentially could be free, but then even if you register, it's relatively cheap. Typical things that are copyrighted are typically music, songs, lyrics, plays, scripts for movies, anything that sort of has an artistic nature or creative nature to it. Trademarks basically are, symbols, words, marks, slogans that can be attributed to some type of source. And the source is typically the company. So trademarks could be something like Coca-Cola or Apple or certain brand names essentially. And it's basically a right to use the mark in commerce, and if you have trademark registration, you can prevent others from using your mark. And it protects sort of the source indicator, which is essentially the company that is represented by that mark. One of the key components about the requirement to obtain trademark protection is that it has to make a mental connection to the manufacturer or owner of the mark. For example, if you wanted to get a mark on the word building, you may not be able to because the word building is generic. However, if you were making mouse traps and your mousetrap company was called Building, then perhaps you might be able to, because it's sort of unique in the space of mousetraps, and over time people would attribute the word building to your company. The term of a trademark is unlimited as long as you sort of maintain your trademark rights. It hasn't been diluted, and so forth. And then the cost of it is slightly more than a copyright because it does still require registration. And there's also an examination process with the trademark office that could incur some costs. Trade secrets, on the other hand, compared to patents, copyrights, and trademarks, do not require registration. In fact, trying to register a trademark may actually avoid your trade secret, because the whole idea of a trade secret is to retain the secrecy or maintain the secrecy. In particular, trade secret has sort of three main components to it. It should be information that is not known or readily accessible by others or competitors. It has commercial value or provides a competitive edge to the company over its competitors, and that the owner has to maintain reasonable measures to maintain the trade secret as a secret. So it has to be password protected, limited access, and so forth. What does it protect? It protects secrets. It requires that you maintain secrecy of that information. And the term of that trade secret remains secret as long as it is a secret. So once it becomes available to the public domain, even if it's not because of your own fault, you can lose trade secret protection on that, which is why later on in this discussion, we will be talking about NDAs and so forth, because trade secrets play a big role in that. And then the last thing to maybe cover in just intellectual property protection types is contracts. And this generally comes into play when we think about if you have a contract to get exclusive information from some other entity, or you have an exclusive right to partner with another entity, that relationship or that information that you receive is sort of not available to others, and therefore has value to you or to others that want it together. And so in general, contracts are, they protect transactions and relationships. They require consideration and an agreement. So the parties have to agree to whatever that contractual obligation is. And the consideration is some sort of exchange of value between the parties. The terms obviously defined by the contract, and then that contracts, because they come in all shapes and sizes, the costs may vary. Rob, over to you.
So intellectual property provides a lot of value to companies so long as you actually acquire, perfect, and maintain those IP rights. For example, like Shabi was just mentioning, your IP rights will provide you with the ability to block competitors and counterfeiters from stealing those, inventions or ideas or, goodwill that's backed by your intellectual property. And, just simply having a cease and desist letter can cause disruption to competitors that can, cause delays in production, releases, retooling, stuff like that. You also can deter lawsuits. And, we think of this as the Cold War, where, maybe your competitor and you both have a lot of, patents pointed at each other, and So neither of you are going to enforce against each other because you know there'd be mutually assured destruction. You also can market yourself as an innovator by, marketing patent pending or patented, which provides added value to customers and investors, demonstrating that a company is looking to improve their processes and performances. And there's also advantages such as deterring counterfeiting by marketing those, patented or patent pending. You also can, if you have that competitive advantage that's backed by your IP, you can charge consumers a premium for that competitive advantage. And you also can generate and realize license revenue, just a separate form of money, that's capital that's coming into the company, just that wouldn't otherwise be there. Something to mention, and we'll talk about this a little bit more when we touch on implementing and developing an IP strategy, is that there's a lot of different ways that you can protect the same product or service. And so that's why you really need to have a comprehensive IP strategy. You can have patents or trademarks, copyrights, all of which that are going after the same product or process. The one caveat there is that, like Shabi was mentioning, part of the requirements of obtaining a patent is to disclose that, how to make and use it, make and use a particular product. So that limits the scope of the trade secret protection that's available to you. So a major part of IP strategies in general, and Shabi's going to touch on this a little bit, is determining whether to file a patent application, pursue patent protection, or maintain a trade secret. And the processes are very different. And like Shabi was saying, the cost is a little different as well. A patent application, you need to prepare and file like a description and drawings of how to make and use your particular invention. And that gets filed with the patent office. So there's some upfront costs there. Then there's back and forth between you or your patent attorney with the patent office on whether or not you're entitled to a patent on that particular invention. And then you have to pay fees to grant and maintain the patent. Trade secret sounds in the abstract relatively straightforward. You just need to maintain a secret. But part of that is there's a lot of back-end work that needs to be put in place to allow your company to maintain that secret. You need to have policies in place on availability and access to particular information, that confidential information that's you're trying to protect. You should have regular training with your employees that have access to that information on their duty to keep that information confidential. Anytime there's a third party involved, you should have NDAs in place, and Shabi's going to talk about that later on why that's so important. But it's a lot harder to maintain a secret than just simply in the abstract maintaining a secret. You need to identify any risks of leakage, whether that's an employee that maybe is opening up emails that expose company systems. You need to make sure that that's buttoned up. Anytime someone's touring a factory, make sure that that's anything that's protected or viewable. Make sure that there's, like I mentioned, NDAs in place. Employment agreements and termination. You should be looking at both at the front end and back end so that employees know and understand their duty to maintain trade secrets and maintain all that information is confidential.
Great. So the one thing I will add is very commonly what we get to hear is if a company's thinking about filing a patent or they're not filing a patent, they typically will just say, no, we're going to keep it as a trade secret. and they think that the discussion should stop there. And we caution companies when they do that, because to maintain that trade secret, you still have to sort of maintain or show that you have policies in place where you've taken the reasonable amount of measures to maintain that information as a trade secret. And depending on the value of that secret, or the how easy it is to maybe identify it, those measures need to be tailored based on the type of information. But going over to the sort of the balance of scales for whether to file a patent or to try to protect a particular invention or pieces of information as a trade secret, there's certain factors that come into play. Now, patents and trade secrets can exist at the same time. And one example may be that, let's say you have a method of generating a tire or manufacturing a tire, and you've got a novel method that has multiple steps, and one of the steps is like apply heat before you wash the tire, and in that process, one thing that you have identified is if you provide heat at, let's say, 300 degrees Fahrenheit or 300 degrees centigrade, that really changes it or improves the efficiency or improves the performance by some percentage. And you want to maintain that 300 degrees centigrade as a trade secret. You can do so as long as we're able to provide a broader range in our public patent filing. So if we say apply heat anywhere from like 100 degrees centigrade to 500 degrees centigrade, we should be able to do that, and you can maintain the 300 value as a trade secret, because with the hope that somebody would have to sort of reverse engineer or try to, by trial and error, discover that 300 degrees is that magic number. But in terms of the factors for, deciding whether to pursue something as a patent versus a trade secret, you want to see if competitors can independently create the feature, or can they reverse engineer that feature. If they can reverse engineer it, then you would likely want to get patent protection on it, because it is a matter of time before they figure out how to do it. If it's something that's really hard to reverse engineer, then you try to keep it as a trade secret. So, for example, when you're cooking, or if like you're a chef, you can keep certain recipes as trade secrets because it's really hard to reverse engineer the exact measurements of different ingredients. Similarly, if the feature is, if you can detect the feature from the use of the product, then that is something that you would want to patent protect, because it would be easy to know if they are performing it, or if they come up with a similar product, that they are infringing. The same goes with the next point on infringement of patents would be detectable. That if you can if you know that somebody would be, by using that product, if they, if they're using the product and you can detect that they would infringe your patent, then you'd want to pursue a patent on it. On the last part, one of the other things that you have to consider is, what is the likely scope of patent protection you're going to get? Is the scope going to be relatively broad in view of the prior art, or is it going to be a very narrow, specific implementation? And if you feel like you can get broad protection because you're a first mover, there's nothing else that's been described in the prior art, that would sort of mean that it's more likely that you would be able to detect patent infringement, because the claims are going to be broader. The only other point maybe to bring about is, if your innovation has multiple design arounds, and so your protection is limited to one solution and there are multiple design arounds it, then getting patent protection may not be as beneficial, because somebody could sort of replace your innovation with 4 or 5 different other ways of solving the same problem. So that's sort of a good way to detect whether to pursue patents or keep an innovation as a trade secret. And sometimes it's a matter of keeping them both. So then moving on to how do we develop an IP strategy? And one thing to think about here is, in typical or in smaller companies, I'll say, what may happen is a company is not really thinking through their IP strategy. And instead, what they try to do is, as they come up with new innovations, if it so occurs to them that maybe that's something they want to protect, they'll raise it and then they'll find patent counsel and say, hey, we have an idea, we want to protect it. But, in general, more sophisticated companies generally have patent counsel or IP counsel internally that really devise an IP strategy that thinks about the company more holistically, allocates a certain budget to the IP, and then sort of works within that budget to see what to prioritize and maybe what not to prioritize. Rob, next slide, please. Thanks. So Rob came up with this acronym SPADE, which might be a good tool for you to think about when you're thinking about setting up goals for an IP strategy. So one of the things with an IP strategy is that you want to be able to systematically identify and protect new innovations. And we'll talk about sort of the more specific details on how you do that. But you want to basically continuously review product roadmaps, partnerships with other entities, product releases, to identify innovations that the company will be developing. And then once you've identified those innovations, you then have to make a decision on whether there is value in protecting them and what the best form of protection may be. Sometimes it is filing patents, sometimes there's not enough value in filing the patents and you'd rather preserve something as a trade secret, for instance. The next part is, when you think about an IP strategy, you always want your IP strategy to work for you, which means that you want to position the IP against competitors, which can involve sort of evaluating what your competitors have in terms of their own IP, in terms of the patents they might have, and just get a sense of the general landscape, patent landscape around you. And the value of this is when we think about filing IP for companies, we typically want to know who are your biggest threats and why do you want to file IP? And then we want to make sure that the patents are being tailored towards what a competitor is likely to do, so that we can prevent them from doing whatever they're likely to do. Internally, you kind of want to align the legal, engineering, and business teams. A lot of companies sort of don't have that alignment, and what ends up happening is the engineering team develops a product, they forget to inform legal, the business team rolls out the product, and because patents, for instance, have like a clock by which you need to file by, oftentimes some patents may not have been filed on time because they missed the date to file and they never communicated with legal. And so when developing an IP strategy, you want to make sure that you've aligned legal, engineering, business teams so that every decision is sort of vetted, and then you can release products. If IP needs to be filed, it will be filed timely. The next thing that having a good IP strategy does is it actually develops a culture of innovation, and it does so via streamlined processes. And typically what that would entail is you would have regular meetings with key stakeholders to ask, where you're encouraging people to share ideas to identify what their innovations are. And in doing so, you're able to develop this culture. And we'll talk about some of the tips that in the next slide about how that comes into play. The last thing about a good IP strategy is that it allows you to efficiently utilize your legal spend. So, every company has resource constraints and decisions have to be made about how much money they want to allocate to IP. Now, if you don't have a streamlined process or where you're sort of making intentional decisions, what might happen is you start filing patent applications on some of your earlier ideas, only to realize that your core competency or some of the ideas that are really important, you've kind of run out of budget because you spent too much early on. And so part of the IP strategy is to really identify all of your IP assets or IP or potential IP assets, and then allocate budgets to each of them so that you're prioritizing your spend on high value competitive differentiators. Next slide, please. Great. So how do we develop an IP strategy? And here are some just simple steps that people can take internally within their companies, to form or to develop that IP strategy. So the first thing that they should do is really form an IP committee that includes key stakeholders from legal, engineering, and business. Oftentimes, when you're early on, you try to bring in an outside counsel to help you sort of formulate those committee meetings and then sort of sit down and set an agenda. But if you're big enough, then you can kind of do this internally with your in-house counsel or legal function. The next thing you do is you routinely evaluate your product roadmap and new releases to identify innovations. And by doing so, and by understanding what that roadmap looks like, you can timely protect your innovations. And I mentioned timely protect twice, and Rob's going to cover sort of the components on the timeliness there on the IP front, on the patent front, because it is an important factor. Obviously, when doing your IP strategy, you always want to keep in mind what the competitors are up to. So monitor competitor patent filings, try to get access to their product roadmaps or at least their websites, and whatever else they're saying in the press about where they're headed, and try to be ahead of their game so that if they're going in a certain direction, you're filing for patents in advance of their releases to make sure you've got some protection in place. Implement a patent incentive program to encourage new ideas. A lot of larger companies do this, where they reward inventors for contributing ideas or identifying ideas to the right people within the company so that they can be pursued. And these incentive programs can pay a certain amount of money, simply for identifying an idea, but then it can also be once a patent application is filed, and then you can award more money or money at the end once a patent is even issued. And so it even helps with retention, because some inventors may be motivated to stay until their patents are issued because they can get some sort of a bonus. Again, you want to always provide regular training and reminders on confidentiality obligations. These IP meetings that you'd have will touch on confidentiality, and it serves as a constant reminder to the team that we take confidentiality seriously. It reminds them about their obligations, and invariably it prevents them, or at least makes them think twice if they're just socially engaging with people, to make sure they're not saying things that could be confidential, but they kind of it slips out because they weren't paying attention. And then the last thing is, again, establish policy for maintaining trade secrets. You may have trade secrets in your company even today, but if you don't have policies in place for how you maintain them, if they do get breached, you have no recourse. And if you don't make sure that they're known as trade secrets, that becomes problematic. Because people in the company start talking about them without knowing that they were actually really highly sensitive pieces of information. Turn it back to you, Rob, I think.
So, as part of regularly evaluating what's going on in your company, you can quickly identify when you need to file for patent protection, or at least consider that. So first, and we'll touch a little bit more on this in a bit, but you should identify potential bar dates. That's what we refer to these particular dates as. And that's any product launch, public disclosure, updates, upgrades, releases, anything that is public facing in nature. Could be a product launch, going to a trade show, providing a submission to a third party. If there's any kind of disclosure to the public, then the company should look at what's being disclosed and determine whether any necessary patent applications have been filed. Another consideration is if you're trying to raise capital. Oftentimes investors like to see IP as part of their consideration or evaluation. It shows a couple things: that your company's interested in investing in R&D, which shows long-term growth and planning, and that the company is interested in protecting their competitive differentiators, which shows an advantage in the marketplace. If the company knows that that they're having a funding round, should evaluate their IP and consider further filings as needed. Similarly, if your company is engaging with a third party, the company should make sure that they have a clear definition of what IP is theirs versus the third parties. Part of that process is to ensure that all of your patents are buttoned up before you actually engage with a third party. Have clear definitions that this is mine, this is yours, so forth. Some other triggers include and are more related to your product or process focus triggers, and that's if someone on the engineering team identifies a weird or unique problem and then identifies a solution, that solution should be evaluated for patent protection. Even if it's viewed as potentially unique to you or your competitors could similarly be faced with the same problem. Some companies will have invention harvesting or brainstorming sessions where a group of engineering folks all meet together and talk about what's going on in their respective day-to-day work, and you can come up with solutions there, and that often results in solutions that should be protected. And just generally, and Shabi mentioned this, you should continuously evaluate your product roadmap and strategic partnerships, determine whether you want to file for patent protection. So these are what we refer to as bar dates, and that's any public use, disclosure, sale, offer for sale, publication, all of these, whenever one of these come up, both in the US and internationally, you should be considering whether you should be filing for a patent protection. And public use could be just using a particular manufacturing solution at the plant, which is also accessible by the public. Offers for sale, submitting a article for publication at SME or a trade show or anything like that. Those are all considered public facing disclosures. And so it sets in the US, it sets a 1 year time frame from the disclosure date in which you're required to file for patent protection. We always advise to file before that to the extent possible, because many foreign jurisdictions don't provide such a grace period. But pretty much the measuring stick of whether something is public is the same, and that's whether something is publicly accessible and facing.
Right. Rob, real quick, in the context of smart manufacturing or just manufacturing in general, if a product is sold that was manufactured using a particular process, even the sale of that product would trigger the clock, even though nobody knew what manufacturing process was used. If it was sort of internal, the sale of a product that was manufactured using that process would trigger the clock for you to start trying to get patent protection in the US, please.
That's a good point. So you should have a close relationship with whoever, if you're a supplier, and you should have an understanding of when those products are going to be offered for sale, because that could also trigger a bar date without that extra layer of consideration in there. So here are some questions that you should be asking yourself when you're considering filing a patent application. First and foremost, are there any bar dates? Are there any of those public-facing events coming up? After that, what's the state of the art? What's out there? What are your competitors doing? Are there any solutions which are similar to what it is that you are potentially looking at protecting? And then these next two go hand in hand, and that's what's the problem that you're trying to solve, and how is your solution better than what is currently out there? So It's looking at what are you doing differently? What is your competitive advantage? And how is that resulting from the particular problem that you're trying to address? Answering these 4 questions can help you define what is the potential scope of patent protection available, and that can also help you figure out whether it's even worth filing for a patent application.
Great. So I know we have 12 minutes left, so I think we're going to go in overdrive and trying to run through the rest of this so we have some time for questions. So just want to go to the next slide, Rob. Great. So this is just a general definition, or maybe a comprehensive definition of smart manufacturing. It involves computer integrated manufacturing, additive manufacturing, which can cover 3D printing and the sort, adaptability with quick changes in design and production levels. So depending on supply and demand, you can start producing or manufacturing quicker, optimizing the supply chain, intelligent automation and advanced robotics, multi-device communication within smart factories or like IoT sensors and so forth, and then data analytics. And all of these characteristics inherently include some type of intellectual property that ought to be protected. So here's a quick example of, maybe a very simple example of a company that's producing tires. They've developed a novel method for manufacturing tires using an AI model trained to use sensor data from sensors that monitor environmental conditions in the manufacturing plant. And let's just assume that this AI model takes into account temperature and humidity levels to adjust certain maybe conditions in the heater, or like maybe in the amount of ingredients or materials that need to be provided to manufacture the machine. And so you can think about all of the different forms of IP protection you can get. On the patent front, there's methods of manufacturing the tire using the sort of the specific model that we've talked about, an AI system for manufacturing tires. There are other forms of patents that we can think of that are more specific to basically how the sensors communicate with the system, how the sensors may provide that input to then adjust the nozzle of sort of an injection mold or something to that effect. There's, if there was a trademark involved, like for example, tire wear, there would be trademark protection. There's obviously the trade secrets in terms of the information that you haven't really disclosed in the patent application that you file, but talk about maybe the positioning of certain things or the specific, parameters relating to the sensors that trigger certain conditions. And then on the copyright front, you can always get copyright protection on the computer code. All right.
So now we're going to talk about selecting and contracting with particular AI vendors. Before we do that, we just want to provide a little overview of what is artificial intelligence. And basically, the way that AI, machine learning works is it's a way that computers will estimate a particular output given an input. And essentially, a set of inputs are fed into this AI machine learning model, and the model spits out a corresponding output. So there's like 2 phases that go on here. First is the training phase, and second is the utilization phase. In the training phase, we have raw data, which is compiled to generate a training set. So just kind of a simple example here would be, let's say we're trying to train an AI model for computer vision that distinguishes between pictures of a person, a bicycle, or a car. The raw data would just be pictures of all of those items and corresponding labels. So you would compile a training set that's fed into this training program, which basically takes in all those pictures and labels and establishes weights for different parameters that are used for distinguishing between those three different objects. And that's your overall trained model. And the greater size of training set, more variety, the better the training phase, the more accurate the final training model. Once the trained model has a certain degree of accuracy or satisfies some tolerance, the trained model is deployed such that when within the utilization phase, when inputs, a random input is fed into the trained model, ideally it will say, yes, that's a bicycle, or that's, a car, or that's a human. AI and just conventional software, the development processes are very different. Conventional software is very linear. It's, you're trying to achieve a particular function, so you're coding to achieve that particular function. So you've got whatever your requirements are, you design a particular software to achieve those requirements, you implement, test, and then periodically maintain. AI development is a lot different. It's cyclical in nature. It's, first you're trying to determine an objective, and then there's learning, there's the training, selecting a particular, your training set, create the model, evaluate it, update it, deployment, and then go right back and see how else can we further refine the model. It's very much an iterative approach, and it can be expanded in a way that conventional software typically is not. It gets better with time, and conventional software is just different from traditional AI.
Right, and I'll just add that when you're writing contracts to engage with an AI solutions provider, one of the biggest challenges is because the AI sort of technology development model is so circular, and it's very hard to sort of meet a set of requirements because a lot of it depends on the training data that you provide, and there are a lot of other external factors. You have to make sure that you're contracting in a way that is milestone driven. Otherwise, you can be on the hook for a big contract with a solution that doesn't really provide you a lot of value because it didn't work well. So when selecting, sorry, you can go back one slide. When selecting an AI vendor, always evaluate the credibility and the processes of the AI vendor. Make sure they know what they're doing. They should be experts in their space. Otherwise, it's not as simple as long as I have the data, I'll be able to build it. You really need to understand sort of the business needs and the industry that they're operating in to be able to provide better solutions. You want to make sure that the AI vendor is compliant with all regulatory issues regarding the data that they have access to. If it includes personal information, if it includes health information, there's certain regulations that they have to maintain. And if it's your data, then you're on the hook if they're not maintaining it properly. Reputational risk becomes important for some AI vendors, like if they are dealing with government organizations, sometimes there's more of a PR concern if you're affiliated with them. So just keep that in mind when you're thinking about selecting AI vendors. And then always have indemnification clauses that protect you in the event that things don't work out as well. And like I said about the competency and know-how of the AI vendor, the accuracy of those AI models are really dependent on the know-how and understanding the industry. So just, there are a lot of startups in the AI space, and oftentimes people think that they can, if they find a startup that can do it, they run that risk that the startup may have never done it before, and it could be a bad choice in the grand scheme of things. And then when you're defining terms and contracts with these AI vendors, again, make sure you have well-defined performance metrics, and then use those performance metrics for milestone payments. When you're talking about data ownership and control, you want to make sure that you've, contract in a way that you clearly understand who owns what data and what rights each of the parties have, both during the relationship, but even after the relationship. A lot of AI systems rely on the data that they've already seen once to then sort of continue to train their models. And if a company or a client of theirs leaves, they generally don't untrain their models, they kind of build off of it. And so oftentimes when you're contracting, you just want to make sure that those rights are well understood, because they may not be willing to, delete the information or untrain their models, because that's going to be prohibitive for them. Again, data retention and removal policies should be well defined. How long are they retaining the data for? If you leave, how will they remove it? All of those things should again be well defined. And then product liability issues should be sorted. So if you're relying on an AI model that's trained by another entity's system, and something goes wrong, you want to be able to go after them for a failure on their AI model or system. And so just have those well defined. And then general considerations when you're implementing AI in your smart factories or wherever, just make sure you're stress testing your systems for potential points for failure. There could be security breaches that people can then interfere with the way products are developed, that can cause malfunctioning products that can result in fatalities and so forth, which can result in PR concerns, right? And then if the AI model is not trained properly, oftentimes AI companies may either classify certain data points as like corrupted data points so that they can meet certain accuracy metrics on their model. So you just want to make sure that your system is well trained and tested or validated using true company or true real life data to make sure that those adverse events don't really happen. And then always make sure you get additional insurance coverage to address AI solutions. They don't often fall within general insurance or maybe some other type of specified policy. So talk to your insurance carrier to see if you can get additional coverage for your AI solutions.
Well, we're pretty much out of time, so we still have like one section here left. So I can just touch on that real quick and then hopefully answer some questions for whoever can stick around. Just generally, you always want to make sure that IP is owned by your company, and that requires written assignments of all your IP rights from third parties, individuals, back to the company. So for employees, there should be two assignments. One would be as part of the employment agreement, and second would be at the time of filing any IP. There should be some separately executed assignment that we can file with, for example, the patent office. If you're filing a patent application that says, look, this employee assigned their rights to the company. Contractors and service providers, just be careful. Make sure that your agreements, especially when you're working with AI vendors, make sure that it's clear that your company owns the IP and not the service provider. Otherwise, it may be considered work for hire, and potentially they could own the IP there. Customers, typically as part of providing a service, any IP related to that service would be owned by the company, but feedback sometimes can cause issues, whether a customer says, hey, this isn't working, and you come up with a particular solution. Chances are that's your company's IP. But if a customer says, hey, we'd like to see you achieve these particular results, or they define specific requirements and detailed specifications, then it's most likely that the customer might own the IP. So be careful, make sure your agreements are buttoned up. When it comes to IP ownership and joint efforts, joint IP is bad.
Let's just go to the next slide on NDAs, and then we can.
Yeah, it's a good point. So go ahead.
Okay, cool. So I'll keep this really brief. NDAs, you always want to engage in NDAs or enter into NDAs with people that you're sharing confidential information with. Again, when you do execute NDAs, just don't think that you're fully protected. NDAs are very hard to enforce. So only share information that you are comfortable sharing. Trade secrets and other things that you don't want other people to know or that you can't afford the risk of leakage for, do not share those. And then the only good thing about an NDA that helps you is, let's say that you want to file a patent application in the future, you don't want the clock to start. By disclosing something under an NDA, that remains confidential and therefore doesn't start your clock for patent filings. And I'll just end there and see if people have questions for us.
Awesome. Thank you very much for that presentation. Obviously, a lot of materials. We know we are running up to time. I do want to ask just one kind of general question, if you can help me out with that. And then I encourage people to, if you can put your contact information back up there, I think on your first slide, encourage people to reach back out to you. Oh, there you go. Reach back out to you directly. What are the most common missed steps, particularly from small and medium-sized manufacturers? That's a lot of, or small companies, I should say. That's a lot of, who may be in the area of needing to exercise this for the first time, or learn about this for the first time, or take these steps for the first time. What's the most common, I guess, missed opportunities or missteps?
So there are two that come to my mind. One is that they don't enter into NDAs, or they don't have leverage in relationships when they're talking to larger institutional, clients or companies. And so they share too much information, and then they get abandoned or ghosted. So they've kind of given away too much.
Right.
And then the second thing that they do is they oftentimes don't have a lot of money, and so they're preserving their capital. But at the same time, your patent filing clock starts from your first disclosure or your first public sale or first offer for sale. And so you have, at least in the US, 1 year from that first date to file something. And companies are like, when I raise my next round, I'll start filing. And so then they've missed out on their opportunity to file for patents on really their core technology, because that's the, you kind of want to protect the core technology first. So my advice is, it might cost a little more, but it's worth filing those early patent applications because they're generally the most valuable to the company.
Anything to be said about researching patents that might have been filed on a similar technology or anything like that previously, to make sure that you're not stepping on anyone's toes accidentally?
You can certainly do that. It's a double-edged sword when you do that, though, because if you become aware of a competitor's patent assets, you could be liable for treble damages, because if you continue to infringe, they can make the assertion that you knew about the patent and you continued infringing. But I generally suggest that you should talk to an IP counsel about that, not do it yourself, because you can't track it. And oftentimes we might provide companies with sort of a window as to what's out there. We call it a landscape assessment to kind of guide them in the right direction. But we keep it in a way that nobody's aware of what patents they're infringing, so that presumption of infringement or willfulness goes away.
All right, I think we have time for one more question before we keep people too long. But are provisional patents a good tool to preserve that date you were speaking of?
Absolutely. Use them often and frequently. They're the best tool for startups. They're super cheap and do the job that you need them to do.
Awesome. Well, hey, listen, I appreciate you guys taking the time today. Appreciate all the information. I encourage people to reach out to these guys directly. As I said, they work with Lyft on any number of these topics, and encourage you guys to, as the manufacturing audience out there, to utilize their services as well. So thank you so much for Foley, Shabi, and Robert. Thank you so much for your presentation today and the time. Thank you so much, everyone, for joining. Appreciate that. And we look forward to everyone joining us on our next webinar in 2 weeks. We'll be speaking to Raytheon Technologies about one of their projects that they worked on with Lyft. So speaking of new innovations and things that might want to be protected, we'll certainly take all this into consideration as well. So thank you very much, everyone, and have a great rest of the day.
Thank you.
Thanks all.
Bye-bye.